السلام عليكم طلاب المرحلة الثانية، أهلا وسهلا بكم، ويا ربي عام جديد، عام تفوق ونجاح. مادة الكيمياء الفيزيائية سنة أدرسكم بها أنا دكتورة مي إن شاء الله، والمادة راح تكون باللغة الإنجليزية. ونبدي بlecture 1 about units and measurements. We will review some general information about the units and measurement, which is very important to use in the physical chemistry. So math, the language of physics, the SI units international system, MK is based in meter, mass, and time. So the letter M from the meter, K from the kilogram, S from the second. And we will learn some information about the prefixes. The standards of measurement used in science are those of the metric system. All metric units are based on multiples of 10. As a result, you can convert between units easily. At the end of the lecture, we will take some example to know how to convert between units, and in the PDF version of the lecture, there are more examples about that. SI unit prefixes part 1 consist of the larger quantities, which are the tetra, 10 to 12, giga, 10 to 9, mega, 10 to 6, kilo, 10 to 3, hecto, 10 to 2, and deca, 10 to 1. So the factor is the multiple of the number 10, and it contains the large quantities. SI unit prefixes part 2, the smaller quantities in the minus, so it's the DC, 10 to minus 1, centi, 10 to minus 2, milli, 10 to minus 3, micro, 10 to minus 6, nano, 10 to minus 9, pico, 10 to minus 12, femto, 10 to minus 12. Basically, there are 7 SI base units, which consist of the length, meter, mass, kilogram, temperature, Kelvin, time, second, amount of substance, mole, luminance, intensity, candela, electric current, ampere. From these base units, all other SI units of measurement can be derived. Derived units are used for measurement such as volume, density, and pressure. Derived SI units, some example of that, the volume, the unit of the volume, cubic meter, the unit of the density, kilogram per cubic meter, the unit of the speed, meter per cubic second, Newton, kilogram, meter per square second, energy, joule or kilogram, square meter per square second, pressure, Pascal, kilogram per meter square second. Units of length. In SI, the basic units of length or the linear measure is the meter. All measurements of length can be expressed in meter for very large and very small length. However, it may be more convenient to use a unit of length that has a prefix. That's why the prefixes is very important in physical chemistry. The SI unit prefixes for length, the gigameter, 10 to 9, megameter, 10 to 6, kilometer, 10 to 3. This is the largest quantities of the length, and the smaller one is the decimeter, centimeter, millimeter, micrometer, nanometer, and the picometer, which start from 10 minus 1 to 10 minus 12. Units of volume. So the volume is the space occupied by any sample of matter is called a volume. The volume can be calculated for any cubic or any rectangle solved by multiplying its length by its width by its height. The unit for volume is those derived from the units of length. The SI units of volume is the amount of space occupied by a cube that is 1 meter along its edge. This volume is a cubic meter. A more convenient unit of volume for everyday use is the liter, and an SI unit. So in chemical, we use the liter instead of the cubic meter. A liter is the volume of a cube that is 10 centimeter along each edge. So 10 times 10 times 10 equal 1000 centimeter, cubic centimeter, which equal 1 liter. A smaller non-SI unit of volume is the milliliter. So the milliliter, it's 1 divided by 1000 of a liter. So there are 1000 milliliter in a liter. Because the 1 liter is defined as 1000 cubic centimeter and 1 milliliter. So 1 milliliter and 1 cubic centimeter is the same volume. The unit of milliliter and cubic centimeter is used interchangeably. The mass, so now we are going to move to the unit of mass. The mass of an object is measured in conversion to a standard mass of a kilogram, which is the basic SI unit of mass. A kilogram was originally defined as the mass of 1 liter of liquid water at 4 centigrade. A cube of water at 4 measuring 10 centimeter of each edge would have a volume of 1 liter and a mass of 1000 grams or a 1 kilogram. So the gram is 1 divided by 1000 of a kilogram. The mass of 1 cubic centimeter of water at 4 centigrade is 1 gram. The relationship among units of mass are shown in the table below. So the kilogram, 1 kilogram equal 1000 gram. For example, a small textbook, it's about 1 kilogram. The gram, it's 10 to minus 3 kilogram. For example, the dollar bill, it's about 1 gram. The milligram, so 1 gram, it's equal 1000 milligram. Then the milligram, it's 1 to divided by 1000 gram. For example, 10 grains of salt equal 1 milligram. And finally, the microgram, 1 gram equal 10 to 6 microgram. For example, the particle of baking powder is 1 microgram. Unit of energy. Conversions between joule and calories. So for the energy, there are 2 units, the calorie and the joule. And the relationship between these two, 1 joule equal 0.02390 calorie, and the 1 calorie equal 4.184 joule, and the kilojoule is 1000 of joules, and the kilocalorie is 1000 of calories. Temperature scale. Temperature is the measure of how hot or cold an object is. An object's temperature determines the direction of heat transfer. So when 2 objects at different temperature are in contact, heat will be moved from the object at the higher temperature to the object at the lower temperature. Almost all substances expand with an increase in temperature and contract as the temperature decreases. However, there is a very important exception for that is the water. These properties are the basis for the common bulb thermometer, a temperature sensor. So that the thermometer is a glass contain a liquid which is the mercury. The liquid in the thermometer expands and contracts more than the volume of the glass, producing change in the column height of liquid. The Ceres skull. So there are two units for the temperature. The first one is the Celsius, sets the freezing point of the water at 0 centigrade and the boiling point of water at 100 centigrade. The distance between these two fixed points is divided into 100 equal intervals or degrees Celsius. And the sample of the temperature is the C. Another temperature scale used in the physical science is the Kelvin, or the absolute scale. This scale is named for Lord Kelvin, a Scottish physicist. In the Kelvin scale, the freezing point of water is 273.15 Kelvin, and the boiling point is 373.15 Kelvin. So we have to note that with the Kelvin scale, the degree sign is not used. So we just put the letter K. For the Celsius, we have to put the note or the sign degree. Now we will take some example how to convert between factor. So conversion factor is a ratio of equivalent quantities used to express a quantity in different units. So if we need to convert the centimeter to a meter, so if we have or how many centimeter are in 1.32 meter. So we will convert the meter to the centimeter. So the meter is the big quantity and the centimeter is the smaller one. We have to convert from the big one to the small. We just need to time the amount with the factor. So 1 meter it's equal 100 centimeter. So we will just times the 1.32 with the 100 and the result will be 132 centimeter. We use the idea of units to cancellation to decide upon which one of the two conversion factor we choose. So we will cancel the centi with the centi, and the meter is the final unit will we use. So how many meter in 8.72 centimeter? We know the 1 meter it's equal 100 centimeter, or each 100 centimeter equal 1 meter. We have 8.72 centimeter. We just divided it by 100. So 1 meter equal 100 centimeter. We cancel the centimeter with the centimeter and the result will be gonna 0.0872 meter. So when we convert the small measurement to the big one, we will just divide the amount with the factor. For this one, we convert the small one to the large, the large one to the small. We just time with the factor. هاي نهاية المحاضرة، وأكو أمثلة إضافية موجودة بالPDF version لهذه المحاضرة.